everyone, and welcome back to another video. In this particular video, I'll be discussing the particular element which is going to be the pinnacle key in order to sustain the nuclear fusion. And that element is iron. In the initial breakdown of nuclear fusion, you have to look at it from the perspective of a star, which a star itself is a naturally, biologically stabilized and equilibrized nuclear fusion, taking size in its dimensions. And it is stabilized, but in its stability, you then find that it becomes a center field of gravity, which the universe starts spinning around different portions of center fields of gravity. But at the base of any star, for the most part, you would find that first is where the ignition of the combustion occurs. But the further you pull away from said combustion, you start at hydrogen, helium, and you work your way down until you get to the center core of the star. And at the center core of the star, every single element continues into a breakdown of and formulates themselves into the center fusion reactor metal, iron. Why might it be iron? Well, for one, iron is responsible for hemoglobin transmutation, the creation and reception of oxygen exchange between red blood cells and oxygen. It allows the oxygen molecule to bind to the red blood cell. What does this indicate in the universe? Well, if oxygen binds to iron, and oxygen is a ignition molecule, and iron binds said oxygen, you could essentially say that the larger the mass of iron ran with enough electrical constant energy would heat up to such a fusion if it can stabilize itself in an equilibrium field. Because if you do not stimulate these elements correctly, they will not essentially stabilize and remain in a fusion. They will disintegrate. And in order to do so, you must now go up the chain of the elements that create the most stable but smallest stars, which create the most and powerful fusion reactions. If a star is large, it does not necessarily mean it has the largest atomic mass. And the more small a star is, the more condensed its atomic mass is, because it shines brighter. The reason it appears to be of said size, the mass of a star is not based on the flame fusion part of itself, but rather the central core. That is the actual atomic mass of said star. The light that it shines, however, is the size overall diameter. Most of a star is actually gas taking form in a equilibrized fusion. And in order to create this fusion, you would essentially have to create and recreate the atmosphere of a star, a vacuum within, at the center, a center of iron, which in combining elements that create the smallest but densest stars, we could actively recreate now a stable nuclear fusion. The question now is, do we have enough money as an entire world if we all combined energy and wealth? If we all combined our wealth, how fast do you think we would all go broke running $1 billion an hour? $1 trillion is 1,000 billion dollars. Let that number exponentially grow. That's 1,000 hours for $1 trillion. And we expect that this is renewable? Well, no, we would actually have to find that we would essentially have to create a new economic system in exchange, with now wealth being returned into a physically backed value, because right now it's currently just a digitized value, which means you can't base it off of anything. And in order to create enough exchange to have this physically backed value, we would have to stimulate a physically backed value that results in a reset of the entire world's wealth if we were to make this happen. Because now countries would have to base their systems off of, say, precious metals, their natural resources again, rather than just printing infinitely typed numbers into your bank account, which we base our debts off of just typing a computer digit into your account. So, let's get to work, shall we? Thank you.